Hello everyone, welcome back to my YouTube channel. My name is Neeraja AN. I am currently graduating in Sri Venkateswara College of Engineering, Bengaluru, Department of EC, 3rd SEM. In this video, I am going to discuss about the subject Digital System Designing using Verilog in the design and implementation of 4:2 and 8:3 priority encoder. This presentation will guide you through the design and implementation of 4:2 and 8:3 priority encoder. We will explore their fundamentals and practical application and compare their trade-offs. Designing of the digital encoder, we use the logic gates. First, let us study what is priority encoder. Priority encoder transforms a set of input into the binary codes with the highest priority input being encoded. This prioritizes the data input. The CREEP have multiple inputs and few output lines with the property level assigned to the each input. The highest priority input will be determined the output code. Let us understand what is 4:2 priority encoder. A 4:2 priority encoder is a circuit that takes the 4 inputs and produces a 2-bit binary code output that represent the highest order active input. When multiple inputs are active at the same time, the input with the high priority takes as a proceed. The figure shown in the screen is a digital logic design of the 4:2 encoder. AND gate generate individual product term based on the input combination. OR gate combines the product's term to form a final output equation. NOT gate are used to invert the specific signals as needed in the logic equation. First, let us understand the 4:2 encoder with an example. It has 4 inputs D0, D1, D2 and D3, and the outputs are Q0 and Q1. Consider 1 is a turn on of a bulb and 0 will be the turn off of the bulb. If the input were 0, 0, 0, 1, the output is 0, 0. According to the truth table, for the output were 0, 0, so both the bulbs were turned off. And verifying the inputs giving 0, 0, 1, 0, the output was 0, 1. It means Q1 bulb will be the turn off and Q0 bulb will be the turn on according to the truth table. For that same to verify the 0, 1, 0, 0, Q1 bulb will be the turn on and Q0 bulb will be the turn off. For the input combination 1, 0, 0, 0, the output was 1, 1. It means both the bulbs will turn on according to the truth table. Let us study the applications of 4:2 encoder. These are used in the digital system, microcontrollers, embedded system and data processing as shown in the figure. And the advantages of 4:2 encoder were fast operation, simple design and low power consumption. Let us put the 8:3 priority encoder. An 8:3 priority encoder is a digital circuit that accepts the 8 input bits and produces the 3 output bits, encodes the highest priority input, and these functionalities are scan the input bits from the highest priority to the lowest priority. When an input is an active logic 1, the encoder generates the 3-bit codes indicating the input position. If the multiple inputs are active, the highest priority input code is generated. As shown in the figure, it is the circuit diagram of 8:3 priority encoder. It has an 8 input, those are D0, D1, D2, D3, D4, D5, D6 and D7, and it has an 3 outputs, those are Q0, Q1, Q2. Let us understand the truth table with an example. As 3-bit priority 8:3-bit priority encoder has an 8 inputs and 3 outputs. Let us give the input combinations as 0, 0, 0, 0, 0, 0, 1 and the outputs were 0, 0. It means all the 3 bulbs were turned off, and give the another input as 0, 0, 0, 0, 0, 0, 1. It means Q2, Q1 bulbs are turned off and the Q1 bulb will be the glow. And let us give the another input to verify the truth table as 00001 and other 3 digits are don't get. The output will be the 011. For that Q2 Q1 bulb will be glow and Q0 bulb will be the turn off. Let us study the applications of 8:3 priority encoder. These are used in the digital system, microcontrollers, embedded system, data processing and priority interpret handling and bus attribution and digital communication system. These are mainly used in the computer organization in a daisy chain priority interrupts to select the highest priority of the files. The advantages of 8:3 priority encoder was fast operation, simple design, low operation consumption and priority encoding. Let us study about the trends of the encoders. These have low power priority encoder and high speed priority encoder and quantum priority encoder. The architectural trends are hybrid priority encoders, distributed priority encoders and reconfigurable priority encoders. Let us study about the applications of specific trends. Priority encoding for AML, designing priority encoders for artificial intelligence and machine learning application. Priority encoding for IoT, developing the priority encoder for Internet of Things device with the low power consumption. Priority encoder for cyber security, designing priority encode for secure digital system focusing on the prioritization. Emerging search areas are neuromorphic priority encoder inspired by the biological neural network for adaptive priority encoding. Optical priority encoders are used in utilizing the optical internet for high speed priority encoding, and this also memristor based priority encoder leveraging the memristor technology for non-volatile priority encoding. The future directions are integration with emerging technology, integrated priority encoder with the emerging technologies like graphene nanotechnology and 3D stacked integration, advanced materials and devices, exploring the new materials and devices for the priority encoder design, SWAM intelligence based on the priority encoder, developing the priority encoder inspired by the SWAM intelligence principles. Thanks for watching my video. Please do like, share and subscribe to my channel.